Hey, are you interested in learning? Check out our videos. Want more knowledge content? Make sure you've subscribed to our channel.
When it comes to deploying AI models in real-world environments, many people still imagine it as a complicated process filled with DevOps pipelines, GPUs, and endless configuration files. But in reality, deploying a machine learning model in 2025 has become more streamlined than ever, thanks to cloud-native AI services offered by AWS, Azure, and Google Cloud. Let us break this down in a very practical way. Imagine you have trained a model. Maybe it predicts customer churn, recognizes images, or even generates text. The real challenge starts once that model is ready to serve real users or applications. How do you get it online, reliable, and scalable? Let us begin with AWS, one of the most popular platforms for AI model deployment. If you are just starting, Amazon SageMaker is still the easiest entry point. You can train, fine-tune, and deploy models directly inside SageMaker. You simply upload your model artifact, create an endpoint, and SageMaker automatically provisions the infrastructure behind it. The beauty of SageMaker is that it handles autoscaling, A/B testing, and even model versioning. But if you prefer more control, you can containerize your model using Docker, push it to Amazon ECR, and then run it on ECS or EKS, which is basically Amazon's managed Kubernetes service. This is the setup most AI teams use when they want flexibility. You define your model as a microservice, deploy it as a container, and expose it through an API gateway. Now, when we move to Microsoft Azure, the process feels very similar, but with some nice integrations. Azure Machine Learning Service gives you a central workspace to manage your datasets, models, experiments, and deployments. Once your model is registered, you can deploy it directly to an Azure container instance for small workloads or to Azure Kubernetes service for larger production-scale deployments. One of Azure's strong points is integration with the rest of the Microsoft ecosystem. For example, you can connect your deployed model to Power BI, Logic Apps, or Azure Functions to trigger intelligent workflows automatically. Then comes Google Cloud Platform, or GCP, which has taken a slightly different but very developer-friendly path. If you are using Vertex AI, you can go from training to deployment in just a few clicks. Vertex AI manages endpoints, scaling, and even online prediction services. However, if you are more hands-on, you can deploy models in Google Kubernetes Engine or Cloud Run, which supports containerized inference. One major advantage of GCP is its strong integration with TensorFlow and PyTorch frameworks, since Google's ecosystem is deeply aligned with open-source AI development. Now here's the secret most professionals miss. The difference between a working demo and a production-ready AI deployment is not just about the code. It is about monitoring, scaling, and cost optimization. If you are deploying on AWS, use CloudWatch to monitor latency and prediction errors. On Azure, you can use Application Insights for telemetry. And on GCP, Cloud Logging gives you detailed performance metrics. These tools help you spot when your model starts drifting or consuming too much compute power. And another tip, always keep your model containerized with version control. Use registries like Docker Hub or your cloud's private registry. This makes rollback or upgrade easier without breaking the pipeline. So the main idea is simple. You can start small, even deploy a model from a Jupyter notebook. But when it moves to production, treat it like a full-fledged microservice. That means logging, scaling, observability, and security must be part of your design. As we step further into 2025, deploying models is no longer a task limited to ML engineers. Thanks to these managed cloud services, anyone with a bit of DevOps knowledge can get an AI model running online, accessible through APIs, and integrated with business workflows. Once you understand how these three platforms, AWS, Azure, and GCP, handle deployments differently, you will be able to choose the one that best fits your workflow, cost, and scalability goals. So next time someone tells you deploying AI models is complex, you can smile and say, "Not anymore."
How did you feel? Is it helpful? Appreciate our efforts in the comment section below. Hit like button, share with your friends about us, subscribe our channel to get further updates. Stay connected with us on social networking sites. For more free tutorials, visit our website www.learnetguide.net.